Hello everyone, welcome to COMP251, Data Structure and Algorithms. Last week we have talked about the abstract data types. This week we are going to see the very first example of abstract data type that we are going to design and implement. So as we discussed, abstract data type is going to be a model that shows basically shows and implements how we store and give access to a collection of data. So the specification of the abstract data type will just describes how each method, how each operation that you define for the abstract data type is going to affect the data that has been stored in the abstract data type. But it doesn't actually say anything about the implementation, how these operations has been implemented. So something that is important for us is that abstract data type is not going to be only a data structure to store the data, but also, all of those specifications, those operations are going to be important for us. The most important actually aspect of abstract data type is the abstraction, as the name actually also says that. Assume you have a task queue which is going to use an abstract data type, let's call it T. You might actually have different implementations for your abstract data type, just like actually the abstract data type list that today we are going to see two different implementations for that. But one thing which is important is that the task queue doesn't really need to know anything about the implementation, the details of these two different implementation. The task queue just needs to know the operation as that has been defined for the abstract data type T, and both of these two implementations should have the same name for the operation, not only the same name, the same actually signature for all of those operations. But you can basically have two different implementation that totally different, in a totally different way implement the that abstract data type. At the end, how the queue is going to, so you as a programmer actually is going to choose that to write down the task queue. You are going to use the abstract, the implementation first or second is just based on this fact that, okay, I know that the for example, the time complexity of the operation A that has been implemented in the first implementation of T is going to be done in O of n. In the other one, it is going to be O of log n. So just based on the difference between the time complexity or efficiency of the operations, you would choose the implementation, but not based on the details of the implementation. So it doesn't matter how many implementations you have for your abstract data type, all of them are going to follow exactly the same operations and signature for the operations. So even if later on the task queue decides to change the implementation of the abstract data type T, you don't really need to change the code there. The only thing that will be changed is that you just change the implementation of T, and everything in the queue will be the same. So this is important to know that this is actually shows the abstraction aspect. So when we are saying that you have an abstract data type, basically all other programs which are using your abstract data type only knows about the operations and the signature of the operations, but they don't have actually access to the implementation directly. So although it means that the abstract data type is isolated, but this isolation is not total, so you will give the specification of the methods. So here is some diagram that shows what would happen when you are designing an abstract data type. You have two parts. You have some data structures, you have some methods, you might actually have some private method as well. I haven't actually shown them here, but the thing is, when you are implementing your abstract data type, you don't allow anyone from outside, any other program, access to the data structure directly. So basically only through the public methods we can actually have access to the data structure. For example, adding something, you should use the method add, for example, or removing some data from the collection, or finding something, or printing them, or whatever actually other operation that you define for your abstract data type. Okay, let me actually give you some example of the abstract data types, and then we will jump into the implementation of the abstract data type list. The very first example that we will cover today is going to be list. List is a collection of data that store the elements in a sequence, actually in a linear order, and basically your sequence is going to be ordered. So the elements inside the list will be stored in a zero-based index, and you will be able to access to those items based on the index, something similar to the array. But be careful, list is not an array. So the size of the list is going to be the number of items that you have stored in the list. At the beginning, if you just create a list, the list is going to be empty and the size is going to be 0. So you will see that list is not an array, okay? And some other specification about the list, you will be able to add an item to the list at the beginning of the list, at the end of the list, or at some arbitrary indexes. So let me actually just give you an example of where we are using a list. So for example, you are creating a list for a shopping list, for example. At the beginning, the list that you will create is going to be empty, right? And then whenever you actually remember that you need something, you will add an item to your list, or you can basically just insert the items at any position in the list as you want. For example, you just notice that, okay, I wanted to put this item at the beginning of the list because it's more important for me, or I wanted to put it at the end of the list because I don't know, I don't care that much about this, buying this one, or giving some ordering. So you are the one who decided where the item is going to be inserted, and the list as an abstract data type allows you all of these actions, or for example, removing an item from the list or from anywhere in the list. So this is very clear that a list is not going to be like an array, although it has some properties of the array as well, that indexing property. When you are creating an array, you are getting some space from the memory, and you basically tell the memory that, you tell the CPU that how much memory you want. I want an array of size 100, I want an array of size 1000, I want an array of size 10, whatever, right? And the size of the array is fixed. And if you are storing some item in the array, you should know that how many items have you already stored in the array. For example, the size of the array is going to be 100, but you still have actually stored, for example, 3 items there, like, I don't know, something like this. But a list, when you create it, it's going to be an object, which is, if you actually call, for example, how many items are there, the list is going to be empty. So you can actually think of it something like this. And then you would add an item like, for example, add 3 to the list. So the list is going to be something like this, that it only has 1 item, and that's going to be 3. So the size here is going to be 1. And then you all of a sudden going to say that, okay, add another item, for example, 2, and add it to the beginning of the list. So list can actually be like something like this. Now the size of the list is actually 2. If you just ask the list what is the size, how many items are there, it tells you that it is going to be 2. Okay, so it is different than an array. So it is an abstract data type. It's not a primitive data type, or it's not an array. And in Java, actually, we have such an abstract data type implemented in the Java collection framework. So these are the specification for the list that we define. For example, you wanted to be able to add an item to the list. You want to be able to add an item at some specific index of the list. Okay, if you don't actually pass the index by default, we can actually write down the specification in this way that the item will be added at the end of the list. If the index has been passed, it means that, okay, the list is supposed to take the value and put it exactly at the index which is asked. For example, you have a list which is currently in this situation, something like 2, 4, 1, 5, and then you will ask to insert 3 in the position 1. So the list will look like this after you calling that. So that's going to be 2. I said position 1, so it's going to be here 3, 4, 1, and 5. Okay, so you see that you are not supposed to shift the items or anything. List will take care when you actually call add. It takes care of everything for you. The other methods that we can think of is, for example, clear, remove all the methods from the list and make it empty. Index off, you just wanted to check if an item is there and what is going to be the index of that item. Just find, even if you can have more than one copy of the item, so it will, for example, can pass the very first, the index of the very first copy of the item in the list, if there is any. If not, it will, for example, can by default pass return -1. That means that the item hasn't been found. Or you can see that because the list is not going to be an array, so if you want to have access to the items in the list, you wanted to have access to the items based on index, right? The method get can actually give you that access. So it's just like, instead of writing something like, for example, if you have an array and you wanted to look at index I, you would write it as using the square bracket operators, right? But if the A is a list, you need to actually write it as a.get, for example, index I. Okay, so array list is not an array. Be careful. And the other methods like remove, set, we change some specific index, size that tells how many items is in the list, contains, which is going to be a Boolean operator, returns true or false, checking if the item is in the list or not. And many other actually methods you can define and add. There are some actually other forms of list as well. These are going to be completely different abstract data types. For example, abstract data type sorted list is going to be a list of items that will keep the item in a sorted way. So we cannot add or remove from some arbitrary positions as we wish. We can just actually try to say that, okay, add this item, and that abstract data type will take the item, find the correct position, and put the item there. So it always maintains the list to be in a sorted way. There's different ways to implement abstract data type list. You can see that the list of operations that you can define for the abstract data type sorted list is different, is less than basically the abstract data type list in a general form. The other restricted form of abstract data type list is going to be a stack and queue. Basically, sometimes you don't really need to have access to all the items in a list. Okay, so for example, you just care about adding the items from one side of the list and removing the items from the same side. or adding from one side and removing the item from the other side. If it is the case, we can actually define some other abstract data type, like a stack and queue. These are, I'm actually introducing them because queue and a stack, I'm sure you have heard about them. They are very famous data structures in computer science, very simple. They are actually restricted form of a list. They keep the items in a ordered sequence manner, but they don't give access to all the items. They only, for example, a stack only give the access to the items from one side of the, you can actually just think of it as a list which you only will access to the items from one side of it. So the items can be added to one side and removed from the same side. That side will be called the top of the stack. So you can just think of it as a stack of, I know, plate, a stack of books, that when you are going to add something to this stack, you put it on top of the stack. Or you wanted to remove something, you actually take off the one which is on the top. You don't take something from some arbitrary position. I mean, regularly you don't. Okay, so the specifications are going to be, just a very limited set of operations. Just push, that will add the item on top of the stack. Pop, remove the item on top of the stack. Pick will just check that what is going to be on top of the stack. Size is empty, or some other actual methods that you can add here. Or queue, which is again going to be a restricted form of a stack. A restricted form of a list. You will give access to the data to the list in this way that the items will be added to the list from just one side and will be removed from the other side. So if the side that we are removing the item is going to be the front of the queue, and the side that we are adding the items is going to be the rear of the queue. It's going to basically implement the queue. Okay, so first in, first out. The item that has been waiting in the list the most, you are going to remove it first. Again, this is going to be, you have a set of specification operations defined over the queue. For example, add, that most of the time we call it actually enqueue. Remove, that we call it dequeue. Pick, size is empty, and so on. Next week we are going to talk about the stack and queue, and this week we will talk about list. All of these abstract data types are very famous abstract data types, and there are some implementation of them in Java collection API as well.